Okay, today is November 14th, 2011. We're going to quickly go over lesson 4.4, which is finding roots. We'll add that to our objective. Finding roots. That's not how you spell roots. Okay? And then we're going to move on to 4.5. Now, for lesson 4.4, there are two major things you need to remember. What we're trying to find out is the number of x-intercepts in a quadratic expression. We're going to be taking the three a, b, and c, the three variables in our standard form. So our standard form is y is equal to ax squared plus bx plus c.
Is this example one?
Yeah. $228. Okay. So, in order to use this, we've looked at the standard form many times before. What we're going to do is we're going to use, it's called the discriminant. Now the discriminant is actually part of the quadratic formula. It's the part that's underneath the square root. Okay? So, the reason we're using just these numbers is because they're going to tell us how many roots there are or how many x-intercepts there are in a quadratic expression. The formula for the discriminant is b squared minus 4 times a times c. Okay? And now I'm going to give you a couple rules to this. So if b squared minus 4ac is greater than 0, then we have two roots. In other words, there's two x-intercepts. Okay? We'll put that on top. Number of x-intercepts. I'll do the rest in black. If b squared minus 4ac is equal to 0, that means there is one root. One root. And finally, if b squared minus 4ac is less than 0, so a negative number, there are 0 roots. Why did I say roots? Roots. Okay? We're going to go over those examples. Now, I'm also going to give you the reasoning behind this. So, we've put up the quadratic formula quickly here. And if you guys notice, the b squared minus 4ac, that is our discriminant. So what we're solving for is whether our square root, the number we're square rooting, is positive. That would be our first example, where it's greater than 0. If it's positive, that means we know we can find a square root, and we're going to get two numbers. We're going to have to split that equation, just like we did yesterday. If it is equal to 0, the square root of 0 is 0, so that means we won't have to split the quadratic formula. There's only going to be one root, and if there's one root, that means the vertex is touching the x-axis. And finally, if it is less than 0, that means we have a negative under the square root. We can't square root a negative number, therefore we have no x-intercepts. Okay? So, we're going to actually do a couple questions like this. Very first one. Example 1. We have negative 2x squared minus 3x minus 5 is equal to 0. Okay? You need to set whatever standard form. Remember, we need standard form, our y value to be 0. We need to set it equal to 0. Okay? So this is already set it to 0 for us. Our a is negative 2. Our b is negative 3. And our c is negative 5. So we're going to plug this into our formula, which is b squared minus 4ac. Our b is negative 3 squared minus 4 times negative 2 times negative 5. Negative 3 squared is 9. Negative 4 times negative 2, positive 8, times negative 5, negative 40. Okay, so we've got our little equal signs here. So our discriminant is negative 31. And according to our rules, how many roots will that have? Zero. If it's negative. So, in other words, we'll draw a small Cartesian plane here. Oops. That means we're going to have some quadratic, because it still is a quadratic. We'll have something that's either above, the vertex is either above or below the x-axis. Okay? No, we just have to know how many roots there are. So there are 0 roots here. Okay?
I'll do it right now.
0 roots. Next question. We have 2x squared minus x minus 6 equals 0. Same idea. We need to plug it into our discriminant, which is b squared minus 4ac. We need to determine a, which is 2, b, which is negative 1, and c, which is negative 6. Our b is going to be negative 1 squared minus 4 times 2 times negative 6. Negative 1 squared is 1. Negative 4 times 2 is negative 8. Times negative 6 is positive 8, which gives us positive 49. The number itself, the actual absolute value, as long as it's above 0, it's a positive number, that's what we're looking for. So because it's above 0, we're going to have 2 roots. And in other words, we're going to have some equation, small Cartesian plane again. It'll be something like this, where it's crossing the x-axis. So those are 2 different examples, okay? It's going to have something like that, and if you notice, there's 2 roots here on each of these. Finally, example 3. Finally, 3. We have x squared minus 10x is equal to negative 25. We need to convert this to standard form. So in other words, I need to bring negative 25 to the other side. So we'll end up with x squared. Sorry, that's 10x. Minus 10x plus 25 is equal to 0. Now I can put it into my discriminant, which is our b squared. So we have negative 10 squared minus 4. A is 1. And c is 25. We get 100, subtract 100. 0. In this case, there is 1 root. And that means it's going to look something like this. We're going to have a quadratic where the vertex touches the x-axis. So the vertex is our x-intercept. So this was our first equation. We said it had 0 roots. We plug it in. There it is. Our equation has no roots. We've now plugged in our second equation. We'll hit enter. We said it had 2 roots. We take a look. This one has 2 roots. Worked out perfect. Our discriminant was right again. All right, last equation. We said it had 1 root. We check it out, and the root is at x5, it looks like. So this is where the vertex is just touching the x-axis. Okay, so we have a couple plots on a graph here. By looking at it, we can make the assumption that this is going to have a quadratic relationship. We need to make an actual model. We need an equation of this. So I don't have x-intercepts, but I have what looks like will probably be the vertex of this equation right here. So the vertex we have is going to be at 2 and 22. So that means I can put this into vertex form, which we had learned before. So, again, sorry, here's our vertex form. We need to put it into vertex form. So, we have y is equal to a, x minus h squared plus k. Now remember from our vertex form that essentially our x value is going to be our negative h, and our k value will be the y value of our vertex. Okay? So in other words, when we go to plug this in, we have y is equal to a, x, we're going to end up with negative 2 squared. This was a positive. And our k is 22, so we add 22 to this.
So if it was a negative, it would be plus 2, right?
Mm-hmm.
We got an x and a y.
Yeah. So we have to solve for a. I realize that looks like a weird 9. That's an a. But we also have the variables y and x right now. So I need another point along this. From looking at it, probably the one I'll be able to estimate best will be right here. I'm going to say it's at 0 and 2. Okay? So there's another x and y value. That means I'm going to replace the x in this equation with 0 and the y in the equation with the number 2. So we get 2 is equal to a, 0 minus 2 squared plus 22. 2 is equal to a, negative 2 squared plus 22. 2 equals 4a plus 22. Now I need to move 22 to the other side of the equation. So we get 2 subtract 22 is equal to 4a. We get negative 20 is equal to 4a. And when I divide both sides by 4, a is equal to negative 5. So our actual equation is y is equal to negative 5 x minus 2 squared plus 22. So we determined the algebraic model. That's what they wanted us to do for question A. Yeah, you had to know this type of stuff. So this was A. Question B says, use the model to determine when the rock will hit the ground. So in other words, they're looking for the x-intercept. Okay? So we're going to use the equation we have now to determine that. What we're going to do is we're going to set this equation equal to 0 because an x-intercept, we know, will have a y value of 0. And we got to find the x. So we're going to plug 0 in for y and solve for x now. So we'll do this in black. Just put a little line down here so we know we're doing a different calculation. So we have 0 is equal to negative 5 x minus 2 squared plus 22. I need to bring 22 to the other side of the equation. My goal right now is to isolate x. So when I bring 22 to the other side of the equation, it becomes negative 22 equals negative 5 x minus 2 squared. Now remember, we're working with, whenever we're trying to isolate a variable, I want you guys to almost think of reverse BEDMAS. So the first thing I did is I actually dealt with the addition and subtraction. I moved that first, when normally in BEDMAS, that's the last thing we deal with. Now I have a bracket, an exponent, and multiplication. In BEDMAS, I would go brackets, exponents, multiplication, but because we're trying to isolate, we're going to reverse that. I'm going to deal with the multiplication first. So I'm going to divide by negative 5. I want to bring the negative 5 to the other side of the equation. So I'm going to be left with negative 22 divide negative 5 is equal to x minus 2 squared. Now a negative divided by negative will get a positive number. Okay, is that what it's going to be? Let's figure it out. 22 divide 5, 4.4. So we get positive 4.4 is equal to x minus 2 squared. Again, reverse BEDMAS. Normally I deal with the brackets, then the exponent. But because it's reversed, I need to move the exponent, which means I need to square root both sides. I'm then working with the square root of 4.4, which is going to be now equal to x minus 2. I actually don't need those brackets anymore. Let's find the square root. 2.0 2.97. We'll try not to round too early because we still have another number we got to bring in. So 2.097 is equal to x minus 2. Now, here's what's very important. Remember, a square root has more than one answer. In fact, it has two answers. I need to make room for it. The square root of 4.4 is actually positive and negative 2.097. So, because there's a positive and negative answer, I need to now split this to two equations. I need 2.097 is equal to x minus 2. And I need negative 2.097 is equal to x minus 2. I'm going to be getting two answers, which makes sense if we go and look back up at our quadratic. If we actually connected the dots, we're going to have one x-intercept here and another one over here. When I move the 2 over, it becomes positive. So we're going to get 4.097. And at the other one, we're going to have negative 0.97 is equal to x. So my two x-intercepts are 4 point, let's round it. We're going to say approximately 1 and 0. And we'll round the other one to negative 1 and 0. We will look at our graph, positive 4.1 and negative 1. It is. Give me a second. So we had negative 1 as one of the x-intercepts, which makes sense. That looks like it'd connect. And our other one is around here, 4.1. Now, which of the x-intercepts represents when the rock is going to hit the ground? I have to make sense of this. 4.1, right? The rock was thrown from 2 meters above the ground, or 2 feet. And then after 4.1 seconds, the rock hits the ground again. So our real answer, because we have to discern from the two of them, is this. The rock will hit at 4.1. And what we're going to do is we're just going to prove this. Okay, so we have our equation. We just want to make sure we are right. We take a look at it. Wow, it has a very high, it's been thrown very high, but in terms of our x-intercept, yeah, that looks like that would be roughly 4.1. So we have the right numbers. Okay. So we have revenue and cost productions. They have this company, they plant trees, and the revenue of this company is modeled by this number, or sorry, this equation. The cost to this person is modeled by this equation. The question wants us to find profit. What that is, the equation for profit is going to be your revenue, so the amount of money you take in, subtracting all the costs you have. So what we're going to do, since this is profit, is we're going to replace revenue with the revenue equation, and we're going to replace cost with the cost equation. We're going to name this P at X, because our only variable in both of the equations will be X, so then we'll have P for profit. So our revenue equation, we have 90 plus X multiplied by 120, subtract X, minus, remember this was just revenue. Our cost function is 8 times 90 plus X. Now what they want to do is they want you to first get the equation for profit. That will be our point A. So find the profit equation. Let's say in standard form, okay? So I want it in standard form. Profit equation in. That's right. So in order to do this, we need to distribute, expand, and simplify. So we're going to take this profit equation. And the first one we're going to FOIL. Okay? So our first terms are 90 and 120. So 90 times 120, 10,800. Junior. Then we take the last numbers, which would be negative 90x, negative 90 times x. Inside numbers, x times 120 gives us positive 120x. And finally, positive times negative x is negative x squared. I'm going to make some room here. When we go to distribute our other, all we have to distribute is the number 8 by both numbers. So 8 times 90 is going to be 720 plus 8x. Now, in order to drop these brackets, first I'm going to simplify these terms, and I'm also going to apply this negative into the brackets. So when we go to simplify this, I'm going to get 10,800. Negative 90x plus 120x is going to be positive 30x minus x squared. When I apply the negative to both numbers, we'll get negative 720 minus 8x. I'm then going to put things in order and simplify terms. So I'm going to move my x squared, negative x squared, sorry, to the front of the equation. I'm then going to collect my like terms for x to the power of 1, which means we're going to have 30 minus 8, which will be positive 22x. And finally, our constants. We have positive 10,800. Subtract. Oh, it is 10,080. Good. Plus 10,080. So question B. Okay, so question B means they want us to maximize profit. So we have our profit equation. It was P at x is equal to negative x squared plus 22x plus 10,080. So quickly looking at this, because our A term's negative, I know I'm going to have a parabola that's facing downwards. And also, can anyone tell me what the y-intercept's probably going to be?
-1. 22.
If this is 0 and this is 0, what are we left with? What number? 10,080. So our y-intercept will be, let's say that's the scale of the graph, 10,080. So our y-intercept is 10,080. So again, we have a y-intercept here, and we know our equation is going to eventually face downwards. They want you to maximize profit, which means to maximize profit, we're looking for what part of the parabola? The vertex. This is where we're going to have a max profit. Okay? Now I can plug numbers in, trying to find it, or I change our equation into vertex form. So that's completing the square. We have our P at x is equal to negative x squared plus 22x plus 10,080. Now remember, we need to find the common factor of the first two terms, or sorry, the term in front of the negative x. So we're going to factor out negative 1. We want the x to be positive. So our common factor is negative 1, and we have x squared minus 22x plus 10,080. Now our side calculation, if you guys remember, we used the formula b divided by 2 squared. Our b term is going to be 22. So give us 11 squared is 121. That's right. 22 divided by 2 is 11 squared. Which is 121. So the 121 is the number we have to add and subtract inside the brackets for completing the square. So we get negative 1 minus 22x plus 121 minus 121 plus 10,080. Now remember, we only need the positive term. I want to take the negative term that I put inside the brackets outside. And in order to do that, I have to multiply by the common number, which is negative 1 when I take it outside. So our next bracket reads negative 1 x squared minus 22x plus 121. When this goes outside, we multiply by negative 1, so we get positive 121 plus 10,080. Let's put that line there. I'm going to equate the outside quickly. Now remember we've created a perfect square trinomial by completing the square. 10,080 plus
10,201. 10,101. 10,201.
plus 10,201. Now remember the fastest way to factor will be to find the square root of the first and last term and bring down the operation in front of b. So in brackets squared, the square root of x squared is x, and the square root of 121 is 11. We bring down the negative sign.
That's a high vertex.
It's a very high vertex. So what this says now, here's our h term and our k term. We're in vertex form. If they sell 11 of whatever units they're selling, they'll make $10,201. So, in other words, the vertex, or the highest point of this, was at 10,201, and it's when they sell 11 units, or 11 bags, or whatever it is these guys are selling. We're going to quickly prove it to make sure we have the right numbers. Okay, here's our equation. We go to plug it in. Now look at my scale. I'm zoomed in way too far here, so we're going to zoom out. Might be nicer actually if I just